Okay, guys. So I'm thinking for this week, it might be nice to go through an example, kind of a big example of where we've been, the things that you're supposed to have been doing, and how some things fit together before we move on to the next step. And I'm going to use the garage case as the basis here for the example. Okay, um, so we're going to do a decision analysis example. Now, remember the last time I suggested that you might want to put your uncertainties and your demand or your design levers, if you will, the things you have control over, in a simple table. Okay, so that was portfolios 1 and 2 really. So you should have a good list of those. So for the garage case, of course, the first uncertainty is obvious, the demand. We've talked about that. But let's say there's, in the Boston area, look at the volatility of the real estate market, right? So land prices could be an issue, right? Also, in this economy, right, labor costs could fluctuate significantly, right? So those are three sources of uncertainty. There are many others that we could look at. These things normally, as I've said before, these come from a large committee. This isn't some one person sitting down to figure these things out, right? So this is somewhat unusual in this case because that's what you're doing. And the design levers for this simple example, if we think land prices are going to go down, we could wait a year to build, right, and get a better deal on the lease. Or we could wait a year and get a better deal on labor prices, construction costs. Or we could build now. So there are a couple of different obvious choices. Could do it all at once. When we do choose to build, we can do it all at once, the standard way. Figure out which one has the best net present value and build it. Or we could do, in this particular case, I'm gonna explain a planned stage construction, not the typical one, but a planned one. Okay. And then a flexible stage construction where we're not starting with a set number of levels. We could look at different scenarios for starting at 3 or 4 or 5. Right? And this planned construction, might consist of a rule that has, if demand growth in the previous 2 years is more than 20% of a floor's capacity, then add a floor, right? Otherwise, don't. So instead of just planning right at the beginning to add a floor, the demand is uncertain, right? So let's wait and see. So this gives us a way of planning this out a little bit to see the net present value of that alternative. So if we were to build a decision tree right at the beginning, are we going to wait a year or are we going to build now? Okay. And then the chances are, the uncertainties are, well, the land prices will go up with some probability, they'll stay the same with some probability, or they'll go down with some probability. And we could also include another chance variable. Well, if the land goes up, what about labor? Labor will go up, stay the same, or go down, same thing, right? And then we have a decision. We'll do the base case, the inflexible staging, or the flexible staging. The inflexible, all I mean by that is we'll set the initial number of levels to build and then add to that based on demand. Right? Flexible staging has more to do with, well, let's wait and see, or let's leave that flexible. Let's see which one works best, depending upon what's happening over here, right? In these categories, right? So let's say we build now and we have, land isn't an issue, right? Because we've already we're building it, right? So we've made that decision. But labor can still fluctuate, and that would influence, these stage construction things, right? So these each have net present worths, net present values. So to look at alternatives, one could, let's say, pick a design that says, okay, we're going to build now. We're going to put some flexibility in, and let's assume labor doesn't change, and we're going to do inflexible staging. Has a net present value associated with it. So that path has a net present value, right? All of these paths have different net present worths, right? So in each path represents an alternative that one could consider, right, and analyze in a spreadsheet. So we're going to look at, we're not going to take into account labor for now. We'll just look at now, and we'll look at the base case and inflexible staging, right? We're going to do the analysis for those two, right, in the spreadsheets. So now we're going to look at a base case. Once again, we'll look at the randomness, and I'm going to actually go through the process so you'll see it, and you can rewind and stuff. And then using the Monte Carlo method, we can produce these value at risk charts. They're just basically cumulative distribution charts, right? And then we can program in some flexibility rules for that staging alternative. Now, by the way, there's something we've been talking about marginal cost and optimal cost and all that stuff, production functions. We could, if we wanted to, and then we probably would in a large project. I'm not asking you to, but if we had the data, we could introduce a production function into this problem. So, for example, the capacity cost of each space may have come from this optimal cost function. So let's say, for example, the production function is the number of spaces, and it's a function of 3 input variables: man hours, tons of concrete, tons of steel. Very simplistic, but this could be a production function. And so here we are. And let's say I've calibrated this. I have some data from other projects, and this is the production function that I've come up with. And let's say that I know that the union wages are $45 per hour, per man hour, $23 per ton of concrete, $52 per ton of steel. I know these numbers are not correct. Okay, I'm just making them up. But the idea is, remember, we could find the optimal cost function, right? The marginal production for X1, X2, and X3. The marginal cost for those same 3, and then combine them. Remember that, and we could combine them to come up with an optimal cost function. So if we have 200 spaces, for example, right? The cost would be $3.4 million. And the marginal cost, so the cost per space, would be $17,000. Now these numbers, if you tried to work it out, you're not going to come up with this bottom line. I just made these up. But the point is that one could use this approach to estimate the costs associated with the project. Okay? We're going to use just the constant value, but nothing says that this would not come from something like this. Okay. So in the next, let's see, where are we? Okay, in the next video, I'll go into the spreadsheets, and we'll go through each one in turn.